Hey guys, it's Brandon Miniman from Pocketnow.com. When you hit send on your phone or when you try to access a web page on your smartphone device or your tablet, a lot's happening involving cell phone towers and switches and networking and so much other advanced technical stuff. Today we got to tour exclusively the Verizon Wireless switch located somewhere in southeast Pennsylvania. Can't even tell you where it is. It's the brain of the Verizon network in this area. It's where all of the cell phone towers connect to. It's where everything happens when you hit send or when you go to a website on your device. In this video, we're going to show you exclusively some of the components of that system. We're going to find out a lot of information about how Verizon Wireless's system works and how cell phone systems work in general. It's going to be interesting. Let's get to it. So we are about to enter the switch room, and Dan's going to tell us a little bit about what we're going to see inside.
Inside switch room 2, you're going to see a 3G digital cellular switch along with a ECP complex. Also in this room is our what we call our distribution center, which is data transport, which handles all the internet calls between here and our sister site located in the region. We're also going to take a tour of the LTE equipment for the new network we deployed in the last year.
So this is the 3G equipment in here?
3G and 4G.
And
Everything
4G.
is in this room.
Got it. So you make a call, it goes to the tower, it goes up to the cloud, down to this place, and then into this room, basically?
Yes, it is a choice of here or one of 2 sites.
2 sites, got it. And how does that get determined, which site it goes to? Just traffic and... Got it.
You hear me in here?
Yeah, it's very loud, but hopefully we can pick this up. So, what are all these boxes in these rows?
Well, behind me is the 3G equipment that I mentioned. This is the 5E VCS cellular switch, along with the ECP complex. This handles all our 3G traffic, 1X, EVDO traffic. Everything behind us is fully redundant. The systems are designed to never go down.
Those are for 3G data behind you.
3G data, voice, 1X
voice
data,
and data.
Everything.
What is it about CDMA where you can't make a call and be on the web at the same time?
Well, in the CDMA world, we have parallel networks, one for voice and one for data.
Got it.
What's happening and what's shifting is in 4G, everything is being converged.
Over LTE, right?
Correct.
Interesting, very good. And so Voiceover LTE is going to be a big deal, certainly.
Oh, it will be.
Yeah.
Voiceover IP is a common practice today, right?
Right.
So I have the ability to do that, but in order to do voiceover IP, that type of processing power, that resides on the handheld or the laptop, whatever the computing device may be.
Right.
Voiceover LTE transfers a lot of that computing processing power inside the network,
Right.
which streamlines communications as a whole and actually makes it a little bit quicker to market. So I'm looking forward to voiceover LTE, but we're looking into the future for that.
That'll be great. Any estimated year of rollout for Voiceover LTE?
We had Lowell McAdam made a comment earlier in the year when he gave a talk, and he talked about voiceover LTE.
Right.
That we may be starting trials at the end of next year, but we may not see the reality of that until 2013.
Apparently it's very crisp and clear. Have you heard Voiceover LTE yourself and actually
Personally, I
experienced it?
have not. What has been described to me is it's more a voiceover IP HD,
Yeah.
right? High definition. And the beauty of the high definition piece is not only is the quality a little bit better, but there's also echo cancellation. So if I have background noise, it has the ability to filter that out.
It does that without hardware. Because you can do noise cancellation with a phone that has two microphones, but you're saying Voiceover LTE dynamically reduces background noise.
That's correct.
That's amazing.
Yes, it is.
Very good. So what is inside of all of these things?
A lot of stuff.
A lot of stuff.
Multiple servers, circuit packs, endless amount of stuff.
Got it. And it must require a lot of power to make all of this run.
Yes, actually later in the tour, we're going to tour the power room next, and you'll see the battery backup systems and the power plants that we use to power this equipment. This is our voicemail platform.
Voicemail.
So when a subscriber does not answer his call, he comes to this platform to have his message deposited and retrieved.
So there are a lot of hard drives in here, basically, recording.
Yes, there's multiple drives.
So these 4 boxes cover voicemail for this region.
Now, this voicemail box actually covers for the serving footprint for our 3G network in this building.
Got it. Very interesting. Oh, what regions does this building serve? What
This
areas?
building, the distribution center, actually covers from Delaware all the way up to parts of New Jersey, northern New Jersey.
So if I'm in Delaware and I make a phone call on a Verizon phone, it's likely that it's getting routed through here.
It's a 50-50 chance, correct?
50-50 chance, because then there's another facility. So my call goes to where in this room first, for example?
Well, that's not easy to explain. I mean, there's multiple different scenarios, multiple different ways a call can get processed.
Right.
But you will land somewhere in the access or the acceptance into the distribution center.
Got it. So it depends on time of day, traffic.
It depends what you're doing, things like that.
Making a call from Delaware. I'm calling my grandma in California. The call arrives here, and then what happens to the call to connect grandma's phone?
It would then connect to our distribution center and it'd be routed to our, if it was a mobile termination, to the far end region to be processed. If not, one of our providers would switch it to a local landline out in the other state and then deliver it to your home. Behind me is the fiber distribution for all our 1 gig and 10 gig Ethernet circuits and interconnect our distribution center.
Okay. So how often does someone come in here and change the switches and unplug stuff?
Constantly.
Constantly.
We're always doing growth. We're always changing strategy with protection and lessons that we learn and things like that.
So if you wanted to increase the amount of users that can be, I don't know, making a call at one time or be online at one time, does someone come in here and move some things around?
No, we refrain from doing stuff during the day to protect the customer experience. We'll
Do it at night. But you would come here to...
In an emergency scenario, yes.
Got it. And so the technicians are sort of watching from another location, maybe within this building, some data on a screen to see the health of the network and what's going on, for example. And if they see something pop up, they come down here and they make an adjustment?
Absolutely. Well, later in the tour, we'll actually see where that room is, where we actually monitor our network and control all the systems.
Right. Question I would say I'd have is, current LTE devices can do 10, 20 megabits per second down. If you wanted to go to 100, where would that change happen? Is that like a switch in here?
In multiple places.
Multiple places?
Yeah, it would be. It wouldn't be in here, but it would also be in other parts of our network to achieve that.
And why not just turn that on today? I mean, what's keeping you, at a certain speed until you go to the next speed?
Limitations in technology, development, R&D.
Right.
We want to do what's right for the customer experience.
Because if you turn up the speeds, there might be some problems.
Effect of the network, Things
right.
design. We have things like our LTE Innovation Center to try technologies like that before we implement them in our network.
Right. So in terms of the hardware, what needs to happen with the hardware to go from 20 megabits per second to 150 or something?
So LTE in the specification does allow you to get to close to 100 meg.
100 megs.
But in order to accomplish that, yes, there are changes that have to be made in the spectrum side. You need the pipe to be a little bit bigger. But one of the bigger issues is really more of the hardware itself. If I had a 4G device,
right.
4G devices today manage 2 antennas. So
right.
there are actually 2 independent data feeds to help realize the speeds that we get today. In order to achieve the maximum that the spec calls for, they actually say you need 4 antennas.
So it's up to the OEMs to come out with hardware that have the 4 antennas.
Well, and then you need a companion antenna structure on the local cell sites as well.
Got it.
The cost of manufacturing that right now is cost prohibitive.
Is that LTE Advanced?
No, LTE Advanced allows you to support up to 8 data streams. That would mean 8 antennas.
And what are the theoretical maximum speeds of LTE Advanced?
That I do not know.
It's got to be pretty high.
Oh, it has to be.
So what do we have here?
Behind me is actually our network. It's about a year old now, our LTE network.
So this is the LTE?
Correct. The advantages of this network, differences between us and the 3G, we have the full redundancy like we did with our CDMA networks in this building. We also have geographic redundancy with LTE. Just another hard layer of protection that we have with our systems. We have the redundancy of a sister site should we lose the LTE equipment here.
So what's different about this equipment than the 3G equipment that makes LTE so much faster? Is the equipment different? How is the equipment different?
It's just a new technology. Maybe Harry, you can elaborate more on that question.
Well, it's actually back to the issue that we just talked about, the benefits of LTE. There are spectrum efficiencies that are out there people benefit from, but one of the key differences is what I referred to earlier as the multiple antennas.
Right.
There is a specification called MIMO, multiple in, multiple out. Imagine my phone being able to manage multiple streams coming in. So you combine that spectral efficiency along with multiple data streams that are out there, that's how we're able to realize a lot of the improved speeds.
So LTE is really a combination of technologies that allow for faster speeds.
Absolutely.
So we are in the battery room, and everything you just saw is fed out of this room off of DC power. So these batteries in liquid are constantly being charged and then discharged. The reason that they do this, Dan, is
for when we lose commercial power in the facility, as we're waiting for our generators to start, our systems will actually run on batteries.
so there's two levels. It goes to battery power, then it goes to generator power. If the main power goes down because of whatever reason.
And even in a worst case scenario, it's another layer of protection if our generators don't happen to run.
If your
we can
generators
run on these batteries for several hours.
For several hours. So that was going to be my next question. How long do these batteries last? For several hours.
Several hours.
So all of these batteries can feed everything that happened in that other room. That's really
Correct.
amazing.
This is one of multiple battery rooms in this building. So there's other rooms like this.
There are other rooms like this. Wow. So what are the other benefits of having your own power supply here with these batteries feeding the other room?
Well, as we talk about electronics, anybody that's been at home and they understand that you have your TVs and as electronic goes, everybody sees fluctuations in power when you see flickers in the TV.
Right.
You go away on vacation, they tell you to turn everything off because the feed is not filtered. This design eliminates that. So it actually helps the longevity of the equipment that we saw in the other room, but it is a great alternative where everything comes through, it is filtered through, and it makes for a more constant feed for the electronics.
Got it. So it improves the longevity of the equipment, and also does it help in any other ways?
Helps with stability as well.
Stability, yeah.
Those hiccups that you see out there, I don't know what the end result would be, but with the design that we have here, it eliminates any concerns around that.
As you can see, we are in a much quieter generator room where obviously if the power is lost, those batteries discharge and then they need more power, these things turn on.
Right. They actually power on by themselves automatically, obviously, and transfer power to our DC power plants to keep everything going.
So both of these, there are two of them in here, both of these would turn on, or would they, one would turn on and then...
If the load is not needed, one will shut down.
So kind of intelligently manages.
Yep.
Wow, I'm kind of an engine guy. You know how much horsepower this
These things are quite loud when they're running. You can't be in here without air protection. So.
I'd love to put one of those in a car. You need a really big car. So in terms of power management, every cell phone tower, or most cell phone towers, have their own generating system.
That is correct. Approximately 85% of our towers have generators to them. So while every one of them is designed with battery backup and they are designed for 8 hours of support, they also have diesel generators in there. The reason for the delta between that and the 100% is there are certain towers that might be on top of a building, might be on structures that cannot accommodate that. So we put a lot of effort, a lot of time and effort and planning into making sure that our network stays up and is reliable.
So we are about to enter the control room, although we're going to keep the camera off. What is inside the control room?
Inside the control room is where we monitor all the systems that we just toured in the MSC.
So there will be lots of computer screens monitoring lots of data.
Correct. Yeah, we see real-time information on how our equipment is performing, and if there's any issues, we can react to them accordingly. Dispatching cell technicians out to cell towers.
So people are in here monitoring it 24/7, basically?
This room is handled 24/7, and also we have our network operations control center.
Can you speak to what data they're looking at, what stats they're looking out for in order to respond to problems?
Just the performance of the whole network.
Got it.
I'm Bilal Zaman. I'm a network engineer for Verizon Wireless.
Very good. So I've got some cell phone tower questions for you. Things I think most people have wondered when they place a call on their phone, when they go to a website on their phone. I guess the first question would be in the design of the cell phone tower. They're all the same height, it seems. Is that accurate to say?
They vary. I mean, between 100 feet and 200 feet, in that range, yeah.
Right. And most of them at the top, or all of them, have these what look like tentacles. And sometimes there are multiple levels of tentacles. I know that's a horrible way of explaining them. What are they, and what is their function?
There's multiple arrays of antennas, and if you see different, like you said, layers of them, I guess, typically it's a co-located site, like Harry mentioned earlier. So we'll have, on this tower outside, you have Verizon Wireless, you have AT&T, you have, I think, Metro PCS
Right.
as well. So
Is there a more favorable position, like the bottom tentacles are better than the top?
no, I mean typically the higher the better in rural areas. For more, I mean, the higher you can see, the more you can cover.
Right.
But I mean, the difference is 10 feet, so it's not much of a difference.
Got it. And can you explain what happens when I press send on my phone when I make a call, from transmission of the signal to the tower, and then what happens after that?
Well, it depends on the service we're talking about, but for a 3G service, essentially the cell site acts is relatively dumb. So it'll just send whatever you're requesting onto, as Dan mentioned, the RNC for EVDO or for 1X, it'll come back to the switching office, and it will determine what you're allowed to do, if you're allowed to have that service, for example.
Right.
It'll assign you what we call a traffic channel to allow you to start talking, and it will relay that back to the cell site, and it will send that to you, and you'll have a call up. For
And
4G, the sites are a little more intelligent. They do a lot of that on their own, and that's part of the reason why it's one of the many reasons why it's faster.
Interesting. And that all happens in a second, which is amazing all the time.
Yeah, much.
What determines how many calls can be placed on a tower at the same time?
It'll be the amount of spectrum we're using.
Okay.
They're allocated in chunks, and we deploy them based on the needs in the area. So, if we're talking about a stadium environment, we'll allocate all of our spectrum there. If we're talking about a rural environment where there's fewer users, we'll allocate less. And as we see the need increase, we allocate more, and that's basically a limiting factor in how much we can serve.
And is there a way to increase the amount of simultaneous calls on a tower, or is it just a matter of putting up more towers?
No, there's definitely ways to increase it. There's a lot of sophisticated algorithms that we can deploy that will dynamically shift the
Traffic.
how it's utilized, that kind of thing. Of course, adding a tower will add a lot more capacity, but there's a lot of ways to do it within the equipment you have.
And in terms of cell phone tower placement, you see them more than ever these days. Sometimes they're disguised as trees, which is always funny to see. Are these placed strategically based on, the company anticipates there are going to be X amount of callers here, X amount of callers there, or is there like some formula you use to say they need to be spread 1 or 2 miles apart in order to achieve a certain result?
It depends on the goal of the site. So, for example, we have rural sites that we just want to provide coverage, and those can serve for miles, many miles sometimes.
Right.
So we'll put them. It depends. So we have tools that will estimate propagation of different sites. So if it's the goal of that area is to just provide coverage, we'll just run that simulation and determine where we might need a tower, and we start the search process for a tower there. In the city, it's more frequently a capacity concern.
Right.
So we find the most loaded sites, and we determine how the best way to offload them would be typically by deploying a new site.
It's a combination of factors. Do you foresee a future where cell phone towers are no longer needed? Maybe the phone can communicate with a satellite. It has enough power to beam up to a satellite, and then the satellite beams down to a data center. Or do you think we'll always have to have cell phone towers?
I would say towers are going to be the way to go in the future. They're getting smaller. There's new technologies that are going to allow us to have
more of them and not need a big piece of land or have to rent the space.
Or even smaller towers, mini cells. If you go to Manhattan, for example, you won't see a lot of the towers. They're 20 feet high, and they're on buildings, for example.
Right. You often see them on billboards sometimes and the sides of buildings.
Right.
Very interesting.
Yeah, the deployment of towers is our last resort. I mean, like I said, there's lots of ways we can enhance coverage and capacity with what we have today. So we typically go through all those steps before we say, okay, now we have to go and deploy a new tower.
So you don't want to avoid building a tower because it's disruptive to the area, it's expensive.
Oh yeah, there's lots of opposition to seeing towers in people's backyards, that kind of thing. So.
Can you give me an estimation, whether it's in the tens, hundreds, or thousands, of how many calls a cell phone tower can handle?
It's thousands.
In the thousands. Interesting. I'm not sure what the perception is out there, but that's interesting. And is that the same for data? It can accept potentially thousands of data connections at one time, or is that lower?
Oh yeah, no, it's thousands of voice calls and thousands of data calls simultaneously.
Interesting. And will LTE, voice over LTE, when that becomes available, will that increase the amount of people that can carry out a phone call on one tower?
Yeah. That's the whole idea, is you get a lot more capacity gains from voice over IP because of the nature of voice over IP.
So tell me about spectrum. I think some people understand this, some people don't. You know, a long time ago, Verizon won the auction for the 700 megahertz spectrum, which
Right.
is, what does that mean?
700 megahertz is a frequency range, right? So we operate within 10 megahertz, well, 20 megahertz total, but 10 megahertz on one way in the 700 megahertz spectrum. So your voice is at a certain spectrum when you talk. Your house phone is at a certain spectrum, and your cell phones now are going to be at the 4G phones will be at the 700 megahertz spectrum.
So spectrum, back to physics class, is the frequency of the wave that your phone creates, right?
Correct.
And so is lower better, is higher better, fundamentally?
Fundamentally, lower is better in terms of the propagation of the signal. So.
Because kind of like a subwoofer has a lower frequency, it can go through things.
Exactly.
So lower frequency is better. So 700 megahertz has good, what's the word? Penetration through walls and other structures like that.
Exactly.
And so there recently was more news about Verizon buying Spectrum. What's that about?
Exciting news. Yeah, we talk about spectrum, and we talk about the ability to be able to support higher bandwidths. More spectrum means, more bandwidth, higher
Right.
speeds. We were able to secure additional spectrum with the partnership that we are forming with Comcast, where they were able to free up spectrum for us. We spent $3.6 billion to be able to increase that capacity. In about 75% of the country, we're able to grow by another 20 megahertz, putting us in a better position to handle not only the needs of 2012, but deep into future years.
So can you talk a little bit about the adoption rates of smartphones and how many people are using smartphones in terms of percentage of overall users?
Great question. That number continues to climb, but the last statistic that I have seen is talking about that smartphones, there's over 40% penetration of smartphones, meaning that over 40% of those that have cell phones are using smartphones. One of the interesting trends that we're seeing today is many of those customers are migrating now to the latest generation, which is the 4G LTE smartphones. There have been improvements in that space in terms of battery life, overall capabilities, which is an amazing thing because you think about the 4G smartphones, they're now coming with front-facing cameras to be able to support video chat. That is something that's a growing demand that's out there. It does increase the overall usage, which is one of the reasons why we are working real hard to stay ahead of that demand.
And if I'm a new user and I want to get a smartphone for the first time, it's very likely that I'll pay that little bit of extra first-time investment to get the 4G smartphone because the cost of ownership long-term between a 4G and a 3G smartphone is very similar.
Great point. But let me offset that in terms of the equipment itself. Yes, you may realize a premium for the 4G and those capabilities with the increased 2 cameras on the device. What we have done, though, is we have a promotion that's on right now. It's called Double Your Data. If you buy a 4G smartphone, you get twice as much usage for the same amount of money.
That makes sense.
So the total cost of ownership, actually, when you look at it that way, is either a wash or better with 4G.
And it helps that 4G technologies are more efficient on your end. So
that's one of the keys. That's how we're able to extend that benefit to the customer.
So that was a look at the Switch. I hope you enjoyed it. Very technical stuff, certainly, but hopefully gave you a better idea of what happens when you press send on your phone and that call's connected in 2 or 3 seconds. It's pretty amazing, the engineering that goes into cell phone network technology of today. If you like this video, please give us a thumbs up, and thanks for watching. That's it for now.